Welcome to HCB Yachts. I'm Barbara, and today we're taking you behind the scenes to see how our world-class yachts are built. From our design center to final finish, you'll witness the unparalleled craftsmanship that sets HCB apart. Every great yacht starts with a vision. Here, in our world-class design center, our team brings ideas to life, blending innovation with luxury to create the ultimate on-water experience. We use state-of-the-art technology to refine every detail, ensuring that each HCB yacht delivers the perfect combination of performance, comfort, and elegance. Every HCB yacht starts with a blueprint, but what sets us apart is our commitment to precision engineering. After the concept is finalized, our engineering team ensures every detail is optimized for performance, strength, and durability. Using cutting-edge technology, they refine the hull design, optimize weight distribution, and ensure that every yacht can handle the toughest conditions. Our engineering team works hand in hand with the design team to bring your vision to life. We're here with Ryan. How are you, Ryan?
I'm good. How are you?
I'm good. Can you please tell us a little bit about what you do here at HCB?
Yeah. So my name's Ryan Garrison. I'm the director of engineering. I lead all the new product development, the custom deviations, some of our production. I like to, or everybody says that I'm the one that draws all the pretty pictures and makes everybody upset. So.
How has HCB Yachts maintained its position at the forefront of design innovations since introducing the first mega center console, the 53 Sueños, in 2015?
So yeah, the 53 kind of feels like the start of this whole large center console movement, and it's been a progression of boats since then. So the launch of the 65, the largest center console out there with 600s, that was huge, and we've just launched two new models, the 48 and 56, which was a huge stride in innovation for us internally. We've got a great team here that's full of some brilliant engineers and some great kind of artisans and trades guys to kind of execute that vision. So it's, I feel like we're really pushing the forefront with how we integrate those designs and leading the way. But it started with the 53 and highlighted the market with the 65, and now we're just backing it up with the details. So it's more behind the scenes with things we're doing. It's pretty exciting.
I totally agree with you on the 65 because every time I'm on the boat shows and people pass by and see the 65, they notice that it's huge and it has 600s, and it's such an impact for everybody.
It's funny. I think the idea of multiple outboards was kind of laughable at first, and then it started to get a little bit more accepted, and then when Mercury came out with the 600, that was really, that's what changed the game, because it was finally a power platform that was designed around multiple engine, fast outboard boats and heavy boats. So the larger center consoles, they don't have to necessarily be center consoles, but that's what really accelerated the designs from everybody. So it's been fun to watch it get a little bit more accepted. But yeah, the wow factor of 600s is a lot.
Can you highlight some of the key design innovations that HCB Yacht has introduced since the launch of the 53 Sueños?
Over the last 3 or 4 years, the focus has been around quality, kind of sticking to truth of materials in some of our luxury finishes and how we execute them, but also a little bit of bigger boat mentality with some of the guys. We've that engineering team, we've brought guys from around the industry, and so we kind of implement that either from the higher level design standpoint or into the details. But we've got more of a dedicated machinery space. That's been a focus. Serviceability has been a focus, as well as some of the interior layouts that are fairly innovative. So, and obviously the different power options and performance is what we concentrate on. So,
what new challenges and opportunities does HCB Yacht see in the evolving market for center console yachts?
I think there's several. One, we talked about the kind of multiple outboard market is growing. The idea of larger boats entering that space is growing, and so we've got to be aware of that and prepared. And I think we're diversifying kind of our lineup and innovating along the way. So that's I'm less worried about that, but we're more focused on some of our general arrangement. So, and that comes down to flexibility in the design. A lot of guys come up with some great layouts, but they're not always functional, or they're not. They don't think through all the details and how you can live in one space, but then entertain in it, fish in a space, but then party in it. And so the flexibility and the diversity of how we use our boats is definitely what we concentrate on. And that's boating in general, but we're applying it at a bigger level with the larger boats. So staying in front of that is exciting.
How does HCB Yacht ensure continuous improvement and innovation in their yacht designs?
I think it comes down to quality a little bit, making sure that we're designing quality in, designing for manufacturing a little bit, but also holding those standards through the process, through production, through even the delivery, and ensuring that the experience of owning an HCB is unlike any other. And I think that we strive for that from the beginning of meeting a potential client all the way through the end process. So that's a core focus, as well as from an innovation side, we embrace it. There's plenty of great companies out there, great boats that they figured it out, and if it's not broke, don't fix it kind of mentality. We embrace the opposite, where we question even ourselves to figure out, like, is there a better way to do it? Is there a better way to design it? Is there a better way to use it in the end? So innovation is part of what the HCB brand is built on, and I think we're led from that, from our upper management, from our ownership. Since the beginning, it's been like that. So it's a great product and a great place to work.
How does customer feedback influence the design and engineering process at HCB Yachts?
I think that's super important for any product, for any boat company, is to kind of listen to your customers. We get to do it in a lot of different ways, or service standpoint of following up and making sure that that every owner is happy with the boat in the end. We get a lot of feedback from that, either with failures or with new ideas, or feedback just, why'd y'all do it this way? And it may allow us to kind of question some of those decisions. But the main place that we really take advantage of it is through customization, which sets us apart from almost every builder that I'm aware of. There's plenty of guys that do custom, but they don't offer it or execute it at the level that we do. We've got a entire team of engineers that are built around that customization. So we welcome ideas. If you want to ask for a new hot tub in the back of the 65, we're at least gonna brainstorm it and try to figure out how we would execute it. And then if it becomes reality and ends up being effective, that's where some of those ideas are born. So it's it gives us feedback to improve designs. It also gives us places to innovate. So a lot of times the customizations that are created from a specific client request, through the process of working back and forth of them with the design, we'll realize that, like, man, this is a great idea, and it'll end up becoming something that we offer in the future. So I like to think that we come up with all of the cool ideas, but sometimes it's coming from our clients. So,
Can you tell us a little bit about the craziest customization that you've ever seen?
the crazies.
Yeah.
Okay. We've had a lot.
A couple?
A whole lot. I think the 65 is the easiest to like. One is a bigger platform, so we can we get to do more stuff with it. But we recently did we converted the cockpit of a 65 into kind of a toy garage. So it had a sun pad right off the transom, right in front of the outboards. That was a great space to just lay out, hang out. But it was hydraulically actuated and just became kind of a toy garage, which a lot of our customers are used to having this. It's what you would find on the back of a mega yacht, but we, I think it was able to hold like 3 or 4 e-foil boards and several C-bobs, and it was just, it had that wow factor but also it was functional. So you get to a spot and you can open it up and pull all your toys out. Yep. There was another 65 that was probably one of my more favorite. We converted the shower of a 65 into, we called it the fun locker, but it was the client is more of a charter guy, so they take out lots of groups offshore fishing, but I guess sometimes when you're not catching fish, you got to find other things to do. So the downstairs space kind of became a lounge or space to just hang out and drink, and then they enjoyed skeet shooting as well. So we had a skeet thrower installed on top of the hardtop, but that shower ended up kind of being the fun locker, and you'd open the door and it was a beautiful kind of open liquor cabinet, and it had a gun rack and your fishing rack, and it was just it was a display, but it was also a cool spot. So, but no more showers, so I don't know what they did without that.
From a design perspective, how do you plan for the assembly and production?
That is the puzzle game that starts in the beginning of any project, and some of it's driven in our charter up front. We kind of come up with a methodology of how we're going to construct the main fiberglass parts, but throughout the development process, we're always kind of circling back and talking through the details of assembly in and during production, and how it's going to roll down the line, how to make sure there's no bottlenecks, how to make sure that the sub-assemblies are going to line up with the other parts. It's just a big puzzle on the front end, but we enjoy those puzzles in engineering. So.
What does HCB do differently with the design of the fiberglass?
We do a lot of things different. We spend a lot of time in how we execute inserts or place different items throughout the boat. From some of the deck parts for our cabinetry, we kind of have to have that flush look, as well as on the interior with the cabinetry, and everything fits together nicely. But the biggest thing that we do that I think kind of sets us apart is the method of construction. So we have 3 main elements. It's the hull, the stringer grid, and then a single part deck, and all 3 of those parts make up pretty much the framework of the boat. But that stringer grid is the one that, it's the puzzle piece that really puts it all together. And it takes a big team and a lot of planning on the front end to make that all work. We talk about routing, we talk about systems, we talk about the method that is going to be constructed on the line to make sure that all of those come together, and it allows us to take advantage of every square inch of the interior of the boat, where a lot of guys will have a hull and say a composite grid system or various bulkheads. There's lots of little pockets of air that don't get utilized, and the full stringer grid gets you surfaces everywhere that not only look good, but Behind them is kind of a expanding foam, so everything's insulated. Our fish boxes on the 2 new models are class leading. Our machinery space is all finished gel coat surfaces that everything's planned for where the systems are going to go. So it's just, I don't know very many other companies that are putting that level of time, effort, forethought, as well as cost into designing from the front end. And that's what sets us apart.
This is where our boats truly begin to take shape. The lamination process is the foundation of a strong and durable yacht. In our lamination department, we carefully construct each hull using advanced composite techniques. Every layer of fiberglass is applied with precision, ensuring unmatched strength and longevity. This step is crucial in crafting a yacht that is both strong and incredibly durable. Hello.
Hi, I'm Caleb. Welcome to HCB Lamination Factory.
You.
I'll give you a little tour of all of our fiberglass lamination and all the builds we do here.
Perfect, let's go. What quality control measures are in place to ensure consistency and durability during the lamination process?
Well, first off, starting out every day, what we start out with doing is calibration of all of our equipment. So when we come in the mornings, we calibrate every piece of equipment we use to make sure that we've got the consistency of resin to catalyst ratios and all the mixtures are correct for us to be able to build the product properly.
Okay.
So we start out the day with that, and we go through and calibrate every equipment. Quality control technicians come in, verify that calibration, so before they start their day, all their equipment is running correctly. And then on top of that, what we do after that calibration is done, we have a quality system which we go in through, and we have daily checks of verification of different parts of the build as we build. As we do those daily builds in the quality system, we come back and we verify those through other checks from the team leaders to the quality team members. So from those quality team members to those lamination team members, those checks are consistently done with over 400 checks from the start of the process.
400?
Yes, 400 checks. So there's over 400 checks from the time we spray gel coat on the mold until it goes out the back door here. And that's just, and a lot of those are double checked to verify. So it could be up to, 800 checks if we double check every process. And then, during that build process, there's different testing we do. Those different tests that come out, we'll do some destructive testing, we'll do some gauging, some calibrations of different things, and then, just to make sure everything's curing properly. We test bark-all hardness before we go to the next layer, and then we make sure we sand it properly, and then each team member checks off to say that that's done before they do the next check.
And what is that machine right there?
So that's our resin chop gun. So those guns, you'll see what he's spraying right now. So he's spraying the resin on the back, on the part to wet it out to get it to bond, to the lamination there. So he'll take that and spray that with resin, and then at some point you have those two strands there. And when they're doing like skin, they'll take little pieces of fiberglass and they'll come out and they'll throw it on the part to help it bond to the back side of it too. So now what they're doing now, you'll see them, they're going back after they've wet that out and they're rolling the fiberglass, or rolling the resin into the fiberglass material to help, saturate it so it'll bond chemically to the part. So right now he's wetting the back side of it, and then he'll lay the material on there, then he'll pull all the resin through the fiberglass to get a good bond to the back side. And then he'll come back.
Fiberglass?
That is the fiberglass there. So he's got a pre-cut piece there, and you see how it's got a number on it?
Yeah.
And it's got little markings on the corners, and that's where they line them up with the corners when they wrap it around. We have a layout and a diagram of every part showing you where every piece goes and kind of how all the material is laid up. So we take this diagram here, which has got all of our different cut materials, and that has a number on each piece of material that comes in our box kit that we have here that he's sorting out, and it correlates with a number to the piece of material. So what's really critical on these parts is the fiberglass overlap. So the fiberglass overlap needs to be generally, a general rule of thumb is 4 inches of overlap to get a good bond and to get a good structure. So if you have pieces and they're butted up together, it's weak right there where it's butted up. So you have to overlap this piece here and the piece on top of it over to get more structural bonding right there, and for it to be the strength of the
So it's stronger, yeah.
Yeah, it's a lot stronger. And that's how
This, it says layer B. There's multiple layers.
Yes.
To this?
So there's going to be, they start out with layers. So most of this part gets at least 3 layers on it, and then they come back, and on the transom back there, which is what they're building now, it gets 4 layers. So on the transom, we do 4 layers, and in some areas with the overlaps, you have almost 12 layers of fiberglass on there.
Wow.
And then that's for those, if you see the back of our boats, you'll see the big heavy 600 motors on there. They're very heavy, 1,500 pounds. And then that big motor, that's what holds all 5 of those on there, is the multiple layers of fiberglass on that transom to be very strong. Other competitors use boards and composite boards and plywood and stuff like that.
Yeah.
But we have this stringer grid that goes down in the hull, and that goes on the back of that. You've got that structure where the engine bolts through. Then there's a gap. We put a transom pour material that they actually do right over here. They've done one today. And then they have the hole on the back side of it, and you bolt all the way through that. So it's almost probably close to 7 inches thick of fiberglass and cord material to both those motors on there, so it's strong, can hold it. So this is our 56 Sueños GIX hull.
This is a 56?
This is a 56. It is huge. So kind of showing you here, this is our mold, and this is what our mold looks like before we put any kind of gel coat on there. So the first process we have here is conditioning our molds, right? So one thing we got to do is we got to put gel coat on top of that. So we'll come here, you know, they've got a little bit of dust on it, but they'll go back and clean it up and wax it before each spray. So one thing we do, we will go and wax this with a release agent that keeps the gel from sticking to the mold. So we'll go and prep this and put like 7 coats of wax on this with sealers and wax, and about 7 coats of process over the whole thing. We do that about every 6 to 7 pulls. So every time we pull it 6 or 7 pulls, we come back and re-wax it again and clean it again and prep it.
How long does that take?
So that process takes us about 3 to 4 days to do it right and do it proper and let everything cure. So every time after about 6 to 7 pulls, we'll do a full re-wax, full cure. And then when it does that, then we've also, what you can see here, some inserts for some different functions on the part.
Yeah.
For different pickups, transducers. We've got some inserts that go on the back and the front for your bow thruster and your stern thrusters. And then when all that's put on there and clayed in, and those inserts are made that way so it can pull out of the mold, but you can make that feature in the part, because if not, it wouldn't pull out of the mold if it's in the mold, so you got to be able to pop it out. So we bolt those in, clay around those, and then we pull those out with the part, and then we pull them out of the part, and then we've got that shape we need to do that. But after we get all that put in there, we'll clay around that, and then we can spray our gel coat. And our gel coat, we'll put our gel coat on here, and the way they do this, if you can see how big it is, they'll come back, and these guys come here in the morning, they'll spray this entire side on this side of the hull, and then they'll get,
And then turn it around.
then they'll flip it all the way over, and they'll spray the other side. And then after they let that cure, then the next thing we do, which we do on all of our parts, is we come back, and especially our hulls is very critical, is a barrier coat. So we do 28 mils, or usually 18 or 24 mils of gel coat, and almost 30 mils of barrier coat to help with blistering and different things like osmosis you see in the water from when the hulls sit in there.
Yeah.
And so they don't get that blistering and it damages the hulls. So we put a total of 60 mils, so we'll flip this thing 4 times with gel coat and barrier coat, and then after that cures, then we'll come back and do a skin coat on it. So I'll show you with that skin coat. We can walk up there and look at that. Skin coat is what I was talking about with the resin gun you see.
Uh-huh.
So they'll take the resin gun, and then they have chopper strands that come out, and it chops up little fine pieces of fiberglass, and it sprays it on the mold, and they take a little roller and they roll it out, and then that gives it its protection layer. This is one that they just got done doing chop and skin, so they basically come through here, they roll this out, and then they'll spray that chop and the chop and resin on here to kind of do that. So all this different material right here that we have is all the different core material, the glasses, and the different fiberglasses we use in our hulls. So when I talked to you a little bit about, we talked about the skin and the chop process for the skin coat for the barrier protection. So after that, we get into the bulk layer of our glass. So as we bring our customers in here, what I always try to do is show them everything in their boat, all the different materials. So, everything usually starts out with a heavy glass, which this is like a 3610 material, which is a really heavy glass. So everything we got has different types of glass in it.
Okay.
So, and then there's the reason they have these nomenclatures here for the different angles is because that tells you what kind of stitch pattern it is. So a LTM is a longitudinal and then a transverse, so it goes both ways, 0 and 90. And then there's some glass like we do on the transom, which is what's very different on our boats, where we use a quad material, which basically is this same material here, but it's got stitching at 45 each direction and 0-90 for better strength.
Oh, wow.
So, and what that does is on that transom, we're talking about all those different layers we put on there. We put that strongest material with all that stitching, so it has strength in every direction that the boat could pull in or get structural pull at. And it's for all your different, strength when unknown and known.
So it kind of looks like this, right?
Yes. Yeah. So one side you have is the structural glass, and the other side you have a backing material. So what you do is you see, and one of the things we talk about is, shiny side up, because the reason why we talk about that, the dull side goes down because that's got to bond to the previous layer. So I always put material shiny side up so the bottom layer can bond to the shiny side of the other material.
Yeah.
So this backing material is stitched on here in a facility, and they stitch it on the back side of this layer, and it comes in rolls, and then we get it obviously cut out. But this bonds, you wet out this side, that bonds to the other shiny side of the other glass, and then you got your shiny side up where all your structural glass is. So this is made and stitched on here to actually bond really well. So we have different layers of material. All of them have their different functions. This is more like a biax, so you can see the stitching going this way, and you can see it going this way. So that's what you call like a 0-45. So you can see each one of the stitching going each way.
Yeah.
And then what a quad material will do, you can see the different biaxles and the different thicknesses of material we use. So some of this we put like in our straights and our chines to give us more structural, and then the materials just go different from that. So after we put, here's like a quad, like what we use. This is the material we actually use on our liner. That's very, very strong. It's the strongest material, and they also say it's a 10W, which that just means it's a 10 stitch per inch material, so it's even tighter woven with tighter stitching to be able to do that. And then there's obviously some carbon like we use there, so that's like carbon fiber, which is really, really strong for stiffness. So after we put the glass on, then one other things we use here is we use different coring materials. So this coring material is a PVC material, and it's made for strength and stiffness. And it's also made, so if you had to build this up with layers of fiberglass, you would literally have to put 15, 16 layers of fiberglass to build it that big.
Yeah, yeah.
And that would take days, and it would it'd be a lot of heat on the part, because we're trying to keep heat out of the part. So we use this to fill that gap to get the thickness we want without having to lay multiple layers of fiberglass, and it's lighter. So this is a lot lighter than if we did 14 layers of fiberglass and resin. So that's why we do that. So we have different thicknesses, and they have different strengths. Most of the stuff we use is a 70-pound density. So like if you think of plywood is like 16-pound density. This stuff is 70-pound density.
Wow.
So it's almost 4 times stronger than plywood.
Yeah.
Or a little over 4 times stronger than plywood. So we use these different materials in certain areas. We use some of this stuff like on our hull sides for hull side strength. On the whole hull side, you'll see all that material that's laid up in there, and you'll see the material laid underneath the fiberglass there. You can see the yellow and kind of what's sticking up there, all that material.
A little bit.
Yeah, so you'll see that, and what that is, that's laid on there and bonded over, so you can go 2 or 3 layers of fiberglass, and then 1 layer of that, and that's just as strong as 15 layers of fiberglass. So you do that to fill it in, and it's a lot lighter weight.
Yeah.
So, and then also what we do here is we have different, and we use these on the hull sides too, which this has got carbon in here, and we bond this to the hull side, and you'll see them up there in that boat up there.
Okay.
So what we do is we put those on the hull side.
Yeah, you matched it, you mixed it, right?
Yeah,
no?
yeah. So what they do is they stitch it inside the glass.
Oh, wow.
So they'll stitch this glass, and then they'll run carbon in the stitching, and then they'll put it on there, just like you'd make a multicolored t-shirt or something if you stitch it too. So they actually stitch it to here, then put carbon in this stitching, and then take it out right here and go back to the regular glass. But this is made because when it's on the hull side, it gives you the strength up and down. So when you compress on it, that's what the strength you're looking for. Here is like some of the different materials we use, and this is what I go over a lot with customers. We have things like our Seakeeper. We use this aluminum, this thick aluminum. We got 1/2 inch and 3/4 thick aluminum, and we screw into it. And that, you know, if you ever get on a boat and you're riding your Seakeeper, keeps you from moving side to side to keep your sickness down, you know, you don't get seasick. So these things have to be bonded because it's a big, you know, 600-pound force ball, basically, you know, a 600-pound ball that's moving at 10,000 RPMs.
Yeah.
So this has to be underneath the fiberglass and fully encapsulating glass, and then we drill through our fiberglass into this to bond our Seakeepers, and even our generators we bond into this too.
Wow.
So we put that in certain places where we need to in the build. Then, you know, that's probably the strongest material we use, but sometimes, you know, with this you have to really get a lot of fiberglass on it to get it to bond well. The rest of these materials are specifically designed for lamination, and this is what they call aqua steel, and it is made to be better for lamination and for chemicals to bond to it.
Okay.
And you can also drill and tap it just like you would metal.
Well,
And that what this is used for is for structure, drilling and tapping into, screw retention, bonding different things there. for
and it's
that.
way lighter.
Yeah, it's way lighter than aluminum.
Yeah.
So the option is to be lighter and better there. And then we go, so you got steels, obviously aluminum or steel would be your strongest. Then you've got aqua steel. And then we got Coosa. Now this is a plywood replacement. So a lot of people, older traditional models, some other boat manufacturers, they use plywood. So here what we use is, this is a polyurethane foam board with actually has layer, you can see the strands of fiberglass in it.
Yeah.
And then in the side of it, you can see here, you can see the layers of fiberglass in there too.
Yeah.
And then what this does is it's you know, like I tell you about plywood, is 16-pound density. This is 26-pound density. So it's even stronger than plywood, and it bonds to fiberglass well,
Fiberglass.
and it's really good for screw retention. And the other good advantage to it is that if this gets wet, it doesn't absorb water.
It doesn't.
So it's a really low water absorption. So it takes, once you resin coat this, that's the problem with wood. It gets wet, it rots out.
Yeah.
So this is literally, if it's, you know, covered in fiberglass, it'll have almost less than 5-6% water absorption. So over 30 years of owning a boat, this is what helps, you know,
Wow.
having this material. Then some other materials we use for different structural, which is a little less stronger than this, but it's also really good for structure and bond, is called an Endurabond. And this is more, if you see this kind of looks similar to if you looked at like chip plywood on the side of a house or something like that. So that's basically its replacement right there. And this is a, you know, a PVC, but it's used for structure and bonding, but it's really strong and it won't rot. So like all these materials were made for traditional boat building, was built out of balsa wood and plywood, and this is all to replace it. So they use that, and then they sand that, and it actually bonds chemically. You don't have to sand it really hard, and with wood you have to coat them
Yeah.
with stuff so they don't rot. With this stuff, it won't rot. So you don't have to do a second process to get it to not rot and do different things. And then, you know, like different things we do with the carbons and the Kevlar. So every one of our boats, you know, you're running a boat, and in the bottom of your keel, you have your keel is the very bottom V of your boat.
Mm-hmm.
So when you're driving a boat and you're, you know, you're going to the Bahamas, you're down on a reef, or you hit something right, that'll usually hit that reef, and that'll kind of tear that up.
Yeah.
So that's usually the first thing to hit, because that's the lowest point in the water. So we put Kevlar strips all the way down our keel for a 12 or 14 inch wide piece that runs our entire keel for that structure, for the safety of the customer. Like, so if you accidentally hit something,
This will protect it.
this will protect it, because Kevlar is made using for what? Bulletproof vest,
Yeah.
other things that stop bullets.
Wow.
So it should stop a reef hitting the bottom of it. So we put that down the entire center of that. So that Kevlar is used, you know, heavily there. The other thing we use right here, and we use this mainly for structures on areas, so carbon is really good for stiffness.
Mm-hmm.
So if you've got a piece
This was in the book, right?
yeah, it was
Yeah.
in the back of the book. So that's just like little strips of it we use. There's different design materials or different stitching. You can get that carbon, you can even get that carbon stitched and different, and I don't know if we have it in here because we don't use it, but you can even go like this where this has got carbon.
Mm-hmm.
You can even get materials with carbon and Kevlar woven in it and all different things like that. But this, where we use this at, is any areas we got that's got a lot of flexing
Mm-hmm.
that would cause an issue to probably crack or, you know, structurally degrade. we'll use this the carbon fiber. We'll use that to go in those areas to give it a lot more strength for stiffness this way or up and down. So it's mainly what it's there for, is just a lot of stiffness. And then when we after we get all this built, this is kind of an example of all the layers of material that I just told you about,
Yeah.
how thick they can get. And this is all the different layers. So each one of those rings, kind of like looking
It's
at
a
rings on
layer.
a tree, is rings of the fiberglass that kind of shows you the different layers of material in there. So you look at some of these where there are overlaps. You've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, each one. So you go up in there and you got 14, 15 layers of material.
Wow.
And that's what makes our transom solid, is those 14, 15 layers of material. I'm gonna take you and show you now, we talked about the hull transom and what's different about our boats and the things we do. So I'm gonna kind of show you, they're down here now mixing up transom pour that we put in there. So I told you about the 12 layers we put on the stringer, the liner that we have over there. Now we're gonna pour this transom, which is almost 4 inches thick, of a very high density material that we put in there to make our transom stronger. So I'll show you that. All right, so what she's doing here, she's gonna take this material, she's weighed it out, and then she's gonna start mixing it there. So we weigh out, so these buckets here are 5-gallon buckets of this transom pour material. It's a very thick, heavy material, and what they're doing is they're going to catalyze it so it gets hard, so it gets really strong. So you have to catalyze it. So what he's gonna do is we take and pour it in this transom, and that goes in between the hull and the liner to give us our strength that we need to get that thickness. And that's what gives you a thickness of almost 5-6 inches of thickness in the hull transom.
Wow.
All right, now I'm going to show you the quality process we do here as we do this sheet. So what we do here, on everything we do, we have quality processes here. So in this quality process, we record air temperature, the transom temperature of the part, the material temperature, which is the material that we're using, the humidity, the material batch numbers, we have all that here. Transom cavity fully sealed, that's just a check to say that the transom's fully sealed, so when we pour it in there, it doesn't leak out. And then we've got free of debris and foam, so we check that, make sure there's nothing else in there, so we clean it out. And then when we get done, we do like a Shore D test, so we do some samples on a cup test, and we put the test samples there to make sure, because 24 hours before we do this, we do a test sample, let it kick for 24 hours before we ever do it to make sure the material kicks off. That way we don't pour a transom in a boat and have bad material that could cause us an issue, or something not catalyzing right or whatever. So we'll test that 24 hours before and then come back and make sure that's good before we ever put that on there. So they've got the Shore D right here. They got the transom was 70, this was 72, and the bottom, top, middle, and bottom is basically what they do of a cup test they do. So what I'm showing you here is that all that material we put in here. What's different with our transoms is we've got all this material. You can feel the material kicking off and how hot it gets.
Oh my gosh, yes.
You can feel it kicking off. So what it's doing right now is reacting to what they're mixing over here. So you can feel the heat here, but when you do it down there, that's why that 1% catalyst ratio is very critical, because if you don't get that right, in any kind of fiberglass or resins or any kind of composite materials, the thicker you get the material, the more mass, the hotter it gets. So normally most materials are kicked at 2%. This is kicked at 1% because all this mass, which is over 4 inches the thickness here, if you don't kick it off at 1%, it'll get way hot. It'll get almost 400 degrees if you don't kick it off correctly. So at 1%, it stays under 250 degrees.
400 degrees.
So you have to keep it down to that lower than that 250 degrees to be able to do that. And then right here, what we have is this transom. So you've got all these layers of fiberglass here.
I see.
And that's where we cut it out. We were looking at on that part over there. So that part over there that we were watching build, this is it. So then this transom, you got 4 inches of thickness. Then you've got this thickness here in the transom. So right here, you're over 7 inches, 6-7 inches thick. And then each one of these bulkheads here, so our engine mounts up here, and you've got bolts on this side and bolts on this side. What other manufacturers don't do that we do is they put this knee in the middle. This is what we do, is put the knee in the middle to keep that engine, when all that pressure is pushing on the back of the boat, this knee gives it a lot of strength so it don't push into the transom of your boat. So each one of those, with what we do here, gets structure and strong material to keep that from pressing into the transom.
Once the hull is formed, we bring the yacht to life in assembly. Here, structural components are installed, electrical systems are integrated, and the boat begins to resemble the final product. Here in assembly, the yacht starts to take shape. From installing bulkheads and floors to integrating fuel and water systems, this is where we bring all the elements together. Every stage of the process is carefully monitored to ensure that each component fits perfectly and meets our standards. Every aluminum component is handcrafted here in our weld shop, ensuring strength and durability. Our expert welders shape and assemble aluminum components from custom T-tops to sturdy railings, ensuring every yacht is as tough as it's beautiful. The precision and skill in this shop help create structural elements that stand the test of time. Now let's see how these boats get ready for paint. The paint shop is where craftsmanship meets artistry. Our team uses a multi-layer process for a finish that is as soft as it's beautiful. Every boat goes through a meticulous painting process, from fairing to priming and sanding to the final clear coat, ensuring a flawless finish that lasts. Comfort and style come together here at our upholstery shop, where every seat is handcrafted for luxury and durability. This custom-made quilting machine is one of the only ones in the world that can help you design any stitch pattern that you can dream of. Our upholstery team handcrafts each seating element with the finest marine-grade materials, ensuring durability, style, and the ultimate in luxury. From ergonomic seating to custom stitching, every detail is designed for maximum comfort on the water. We're here with Doug. Can you please tell us what you do in the factory?
Yes, so I'm the small parts fabrication manager. So we do all the plastics and acrylics and the custom cabinetry that go in the boats.
What sets HCB's cabinetry apart from other boat builders or yacht makers?
I think it's the attention to every little detail that we put into the cabinetry. Also being able to maximize the space that's in the cabin to utilize every bit of functionality that goes into it. From adding a cabinet just in a little nook to adding drawers, storage, anything like that. And then I think most importantly is the craftsman attention to detail, the pride that they have in doing the work and seeing the finished product come to life.
How do you ensure consistency and precision in handcrafted pieces for each boat?
I think again, it's the skilled craftsmanship in what they do and also our precise process in the build aspect. Making sure that everything is sturdy, everything is pristine when it's done and it's on the boat and the customer gets just this magnificent piece of art, basically.
What custom touches or hidden details are you most proud of in our cabinetry work?
I think the ones that stand out to me are cedar-lined humidors. One, it's just a cool option to have, very fun to make, and it's something that you don't see a lot of. Also, we've done this real extravagant wet bar that highlighted specific liquor bottles, stemware, and the whole cabinet was just this gloss white with backlighting inside it to highlight all of that.
Yeah.
And then it goes down to our custom inlays on our cabinet doors. It just shows the craftsmanship that we're capable of doing. And then also several of our boats have a curved cabinet. So that's all completely hand done, no CNC machine on it. And it just turns out beautifully. And again, it just shows the pride and the work that the guys put into it.
Would you say they're fun to make? Why do you
It's
think
fun
they're
to make because it's something different.
Okay.
And unique. So always looking for, I guess, like a challenge so that we can say, yeah, we can do that. That's not a problem. And we execute it every time.
What motivated HCB Yachts to incorporate 2 galleys on the new 56 Sueños GIX, considering that in the past models, it was only just 1 galley?
I think it's the capacity and the versatility that it creates. You're able to go down and have a functional galley there with multiple cabinets on port and starboard side. And then from there, options are endless. You can add an extra refrigerator, ice maker.
An ice maker.
Yeah, yep. Potential is there for anything, and that's why it was kind of designed that way. So that if a certain client wanted any specific item, that we would be able to incorporate it into that section. And then you've got the flow and everything's blocked off from the stateroom if you want privacy. And then you've got a nice big open seating area right behind you. So,
Can you go show me the cabinetry work that you do?
yeah, absolutely. Let's go.
Let's go. So now that we're here in cabinetry, can you please walk me through the whole process of from raw material to finished cabinets?
Yeah, absolutely. So we pretty much start here. We have the raw sheet goods, and then we go through and hand pick our veneers to match up, lay them up on the boards, and then from there it'll go back to the CNC machine. And then also we've got curved cabinetry. This is all hand done in a mold, goes into a vacuum bag,
Whoa.
and then it's glued, pressed, cured, comes out, and then it's all hand cut to create what a finished product would look similar to that.
This?
Yep.
Oh,
So this
yeah.
one, right as you go down into the boat, you've got a curved staircase that this will go into, and you'll go into the galley. And this is part of the split galley
The
that I was talking about earlier.
galley.
Yep. Then they'll go to the CNC machine.
The what?
CNC machine.
Okay.
So it's our big robot that cuts out a lot of the shapes. So this is the CNC machine. And that's what it's doing right now. Cutting out a set of our 56 cabinets.
This is so cool.
It is very cool. Precision cuts every time. And also just speeds up production. It's a must-have for any manufacturer. So once our complete set is cut, we'll store them on a rack, and then it'll start the whole process of being prepped in different stages to go into the spray booth. So this is where all the cabinets get prepped. Final sand for the clear coat that goes on it. And then once everything's ready to go into the booth, it goes into our booth here. And this is where we put our clear polyester finish. It's very clear. It'll show the natural beauty of the wood. And from there, it's just a several process of sanding back in the spray booth to build up a durable coat.
So that it looks like this?
It'll look similar to that. This is in the current process right now.
Okay.
So you can see how shiny.
Yeah.
And then from there, it'll go over to our polishing. So we do a final sand and polish, and we end up buffing it to get just a high gloss mirror-like finish.
Wow, that looks beautiful.
And that's our inlay that I was speaking of earlier. So we also fabricate these by hand and then do the same finish process to go on the back of the helm seats. And then from there, once everything's polished up, we go to the assembly stage where we construct all the carcasses of the cabinetry and then attach the faces and the doors and drawers onto it. So this is our finished cabinetry. This is the 56. It goes in the stateroom on the port side.
Okay.
It has a clothes hanger right there. It'll have a door on it when it's said and done.
So this will be like a closet?
Basically, yes. Yep. This is the closet. So this is isolated in the stateroom. So you can hang your jackets, clothes, whatever you want, along with other drawers in the room. But you can see just the beauty of the natural teak.
No, it's perfect.
And with the high gloss finish, it just brings everything out. It's very warm feeling. So it's one of those that teak has went with boats for centuries. So it's always going to be a staple in the boating industry.
So next up, we're gonna check out the wire harness shop. Behind every HCB yacht, there's a complex network of wiring that powers everything, starting from navigation to entertainment. A yacht's electrical system is its nervous system. Here in our wiring harness shop, precision and safety are paramount. Each harness is meticulously crafted and tested to power every onboard system seamlessly. From navigation and entertainment to lighting and controls, every connection is tested to ensure flawless performance. We're here at the HCB headquarters with Cameron. Cameron, tell us, what do you do here?
I'm the electrical engineering manager for HCB Yachts.
I have a couple questions for you. What inspired HCB Yachts to develop the first integrated control system on center console yachts?
So we wanted to improve the user experience. You know, this is a digital world and everyone is more connected to all of their things in life. They're more connected to their phones, their cars, and that brings a lot more convenience. We wanted to bring that same convenience to your boat. We wanted to add reliability, reduce complexity, as well as adding features that a customer is going to enjoy on a daily basis.
What are the key features and functionalities of the new integrated bolt control system?
So the bolt control system is a fully integrated system that HCB developed from the ground up. We developed new software, new graphics in partnership with Garmin's hardware. We chose to do this with Garmin because we wanted a global service network and the reliability that their hardware brings to the table. The system features a 20-inch widescreen at the helm that has all of the monitoring, control, and functionality for the entire boat. In addition to that, you can control many features of the boat on any of your Garmin screens throughout the boat, in the aft cockpit, in the bow, or in the cabin, depending on where you've chosen to put these displays.
How does the integrated bolt control system enhance overall user experience and ease of operations for the new HCB yacht owners?
The HCB bolt control system was inspired by automotive industry and the aeronautical industry and the many advances that they've taken with the simplified user experience. So when you get on the boat, there's one button. You press a single button, the whole boat comes to life. The entire system has these types of features throughout it. There's automation, timers, and simple features in the boat that allow somebody with minimal experience on a boat to operate the boat without getting themselves in trouble. Additionally, we have guided user experiences in the boat depending on what type of activities you're engaging on the boat. So we have a fish mode, a cruising mode, as well as an anchorage mode. And then we've got basically a home summary mode that tells you all of the information that you need at a quick glance on one page.
What does it take to manufacture the backbone of a complex system like this?
It takes a highly engineered design, a well thought out manufacturing process, and a team of highly skilled craftsmen to execute it.
Can you show us?
Absolutely, let's take a walk.
Let's go. We're here at the harness shop. Can you please explain to me what's happening, what's going on in here?
Yeah, so we've got a multi-step process for manufacturing the electrical assemblies. So we start here at the wire cutting station. So these machines are automation machines that pull the wire from the rack. They cut it and strip it to the appropriate length, and it labels the wire from end to end with a big printer on it. From the cut stations, we go over here to the termination stations. Here at the termination station, we take open wires that have no connectors of any kind on them, and then we do a finished termination on it. From this point, we can then take the wires over to the assembly stations and assemble it into a harness. Here we have one of our one-to-one harness layouts. Engineering designs these layouts, and then we supply them to the harness shop where they can take all of those terminated wires, assemble it on this board so that when this harness gets completed and then tested and it gets installed into the boat, every single wire and connector fits exactly where it needs to be. Every wire is labeled full length, so if you can see, we've got printing on this wire, and you can follow this wire anywhere it goes through the entire boat and figure out exactly what it is. After the harness is assembled and tested, it gets loomed so that it's protected from any kind of chafing or damage when it's installed into the boat.
So you spoke about testing these wires. How do you test them?
So we actually have a complex machine that we mate with an opposite harness to a finished wire harness. So we can plug into every connector a mating connection, and in about 30 seconds, a computer program will test the entire harness.
With all these wires that you've shown me, where do they all connect to?
So over here, we're at one of our 6 sub-assembly stations where we build all of our panels and small harnessing and things like that. Right behind us, we've got the assembly happening of one of our distribution panels. One end of the wires generally connects to some form of power distribution, and then the other end is going to connect to various systems or lighting or customer features in the boat.
Before an HCB yacht reaches its owner, it must pass our rigorous lay testing process to guarantee top performance. Our team tests acceleration, stability, and maneuverability to ensure peak performance. We fine-tune engine calibration, steering response, and onboard systems to guarantee a smooth and powerful ride. At HCB, quality is non-negotiable. Our inspectors meticulously check every detail before a yacht is cleared for delivery. From structural integrity to fit and finish to electronic functionality, we leave no detail unchecked before a yacht is deemed ready for delivery. I'm here with Jason. How are you, Jason?
Doing good. How about you?
I'm great.
Good.
Can you please tell us a little bit about what you do here at HCB?
Yeah, so I'm Jason, quality manager here at HCB. I run the quality department. I got a lot of techs and a lot of different checks that go into the build of the boat, from lamination to pre-cap to final assembly to lake test to the electrical systems, leak test, things like that from start to finish.
How many quality checks do you go through in one yacht?
In one yacht, the 56 model alone, we have close to 6,000 AIMS checks start to finish.
6,000?
Oh yeah, it's very, very rigorous.
How do you handle so many? How do you take care of all that?
So we have a lot of techs here, quality techs at HCB, and it's all laid out in a different section as far as pre-cap, lamination, final assembly, late test. Everybody kind of owns a different area as they go.
Okay, can you show us how you do it?
Yeah, so the AIM system, very simple. We have a lot of information for the guys on the line that shows examples of different build options and packages. And each build option and package also comes along with a different AIMS check that the guys can verify that they installed the right part, and then we have quality come behind them and also validate that it's installed correctly as well. So a lot of different AIMS checks that go along with a lot of different parts.
Can you show me an example of one specific quality check that you would do on this boat?
Yeah, so for example, we have an aft sunshade that's mounted in our hardtop here, and during some of the electrical inspections, we have different checks that talk about pressing the button to make sure it extends and retracts. And we have to test this 10 times in and out to make sure that it passes the test.
10 times?
Yes.
Why so many times?
We just like to have a good percentage of quality inspection included in. So it's extended out now. We retract it back in. And this is a 10-time cycle to ensure that it's going to function correctly for the owner.
The final step in the journey. Every surface is polished, every detail is refined, and the yacht is ready to be delivered to its new owner. The journey from concept to completion ends here, with our final finish team making every last detail perfect before delivery. We add the final touches, polish every surface, and ensure that every yacht reflects the luxury and craftsmanship that define HCB. From concept to completion, HCB yachts are crafted with precision, passion, and expertise. Thank you for joining us on this exclusive tour. We'll see you on the water.